All right. Perfect. All right. Thanks everyone for joining. We have a fully packed meetup today, so it's pretty nice. And I will give a small introduction of the Flutter Belgium community. So today we have 20 new attendees. So I think most of them will be from Limmen probably. But nevertheless, it's nice to see the number grow because we're currently with almost 850 members on Meetup, which is pretty nice. And it keeps growing even on LinkedIn and on the other social media groups as well. So Flutter Belgium started in 2018, and yeah, we aim to create a community where everyone's welcome, can ask questions, can learn from each other. That's also why we do these meetups, to share knowledge and to network with other people who has the same interests. We're trying to do a meetup every 2 or 3 months, depends on the hosting company when it's possible for hosting. So yeah, there's always a meetup somewhere in Belgium that you can join across the year. And Flutter Belgium currently is Jens, who's sitting at the buttons for the live stream, because we have a live stream as well. Chris, who started the meetup in 2018, and then me, I also joined 1.5 years ago. Same with Jens. So yeah, if you're not yet in the Slack group, join the Slack group. We have some channels where you can ask questions, etc. Or the other social media links can be found there as well. We also have the Flutter Belgium app, which is pretty bare bone as of now, because we're always saying we want to add new features, but we don't have time to implement it. But we have a raffle at the end of the meetup that you need to sign up to with the app. So if you want to get some nice merch from Flutter, you can sign up. We will share the link, and you can scan the QR code as well on the banners. But we will share the link later, so you can definitely join the raffle as well. We are always looking for new speakers, so it's interesting to learn from other people, but we need speakers who want to tell something that they've learned. And we really believe that everything that you do on a daily basis is worth sharing. And it doesn't matter actually what you actually want to talk about. We have had talks about a project manager who became a Flutter developer, for example. So it does not need to be a very technical talk. It can be anything related to Flutter or Dart. There are some open topics that we maybe still want to cover in a later meetup, so which is Flutter for Web, for example, but also app in app. How does that work? And how do you do full stack in Dart and Flutter? But Robrecht will do a small lightning talk on that. So quite cool to see that we're also looking at other topics as well. If you want to host a meetup yourself like this, it's quite easy actually. We have a document that contains all the information that you need. So if you want to host, just reach out to Chris, Jens, or me, and we'll make it happen. So for today, we have 3 lightning talks from Robrecht, who will be talking about Dart Frog, which is a backend implementation for Dart. Then Pieter-Jan and Robrecht, sorry, we forgot to, or we didn't have a picture, we couldn't find a picture for you. So you were talking about memory leaks. And then Romain has the biggest title of all the talks today. So he will be talking about securely transmitting an API key from an app to a computer using Firebase. And then the main talks will be from Tijl, who works at Limmen. He was previously a React developer, and he transitioned to the good place. So yeah, it's quite interesting to see. I think it's the first time that we have such a topic. As I said before, we don't need to have Flutter specific things every time. It can also be something something like this, which is nice to see. And then William, who will be talking about machine learning, I also think it's the first time we do a talk about machine learning, which is odd, I think, since the last few months, years have been quite AI everywhere. So yeah, pretty cool to see that William will be talking about how you can integrate it in your application in Flutter. And then Verhaeghe has an idea to start a hackathon that we maybe can organize, and let's just talk about after all the talks, just at the networking area. And maybe some things get out of it that we can organize a hackathon in the future. So if you want to join the raffle, this is the QR code, but you can also just scan the banners later. Okay. And then, yeah, one last big thanks to Lemon for hosting. Thanks for the lovely dinner. It was very nice. Also the venue, the networking area, the place that we're sitting at here. It's very nice. We have a lot of people. I think it's the biggest meetup that we've had in the past. No? Equals, yeah. So fully packed today. So thanks again for hosting. And we have some small, or let's just announce the next meetup, which is already in less than a month. And the reason because of that is because Flutter is hosting a live stream, a special live stream that will be hosted at the 17th of December. We don't have any other information, so for us it's quite excited, or how should I say? I don't know what to expect. But yeah, we will be doing another meetup at InvestSuite, which probably will be maybe one lightning talk, 2 lightning talks, and then the live stream. So it will not be the same format as we do today, where there are some longer talks. It will mainly be the special live stream event. So if you want to join us in Leuven. And let's get started with the lightning talks, I think. So Robert will start. Ja.
Ik denk dat ik heb op de knop gedrukt. All right, I think I'm in a safe space to say that Flutter is the holy grail for app development. But the question is, of course, is Dart the holy grail as well? Or maybe not. A quick intro. My name is Robert. I'm a partner at Unlocked. We focus fully on Flutter with our entire team. I love canoeing and I love Flutter a lot as well. So in this talk, I want to take you a bit on the journey which we take for backend development. And yeah, Koen said, so Dart fork is one element of it. But backends, yeah, can be small or non-existent for simple apps. But for complex app, you can have very big, complex, heavy lifting backends as well. And for me, the choice of a backend or not depends a lot on, of course, the app, the complexity of an app, but also the team who will build it. And as we are with our team mostly front-end focused, we love to do backend as well because we depend so much on it. But at some point we say, okay, maybe we need to make other choices. Some say the best backend is no backend. Sometimes like it a lot. When I come across an app which doesn't need a backend and brings great value, because it's very easy to scale. You don't need to scale your backend with it. But much more often, Oh, this goes in the wrong direction, but anyway. Much more often you need something as a backend. I don't know who uses Firebase. I show some hands. Or maybe Superbase. A bit less. AppWrite. Pocketbase. Okay, so there are many backend as a service. Backend as a service is available to help us, app developers, focus mostly on the app and get a lot of backend for free. There's a lot of advantages. Speed, you click a few buttons, your backend is up, you have a lot of out-of-the-box functionalities, and you can get going with your app. Most of them have very good integration with Flutter as well, because they have the standard SDKs, especially for Firebase and Superbase. Don't know about AppWrite. What the status is there. And it's very, very good for small teams, but also very cost effective. I think a Superbase you get for $25 per month. The amount of value you can get from it is much, much bigger. But of course, it has limitations as well. If you need to do some very specific queries, a bit more processing, you already need to start writing some backend logic, and there is then when sometimes the hurdle starts, because which language then to write this logic in. Then taking another alternative is using proxies or middle layers. And this is where we find the sweet spot in using Dart in the backend. There are multiple solutions to do Dart in the backend. I think there are a few big server pod lovers in the audience, but Dart Frog is another backend framework. Dart Frog is not as extensive as serverpod. We mostly use it as a middle layer or a proxy, and then we combine it, for instance, with Superbase. That's where we found a bit the sweet spot for the lighter backends, which we can have control over as the mobile development team. We put, as you can see here, we put a Dart Frog as a proxy before Superbase, so that for all the very standard stuff, you can just use the Superbase SDK, but proxy it anyway through your custom layer. And then if you need integrations with other systems, or you need more specific complex tasks with your database, you handle that logic in Dart Frog before going to the database or going to other systems. Why? In some instances you can say, okay, it's an extra layer, added complexity. So again, it's not always fit for all projects, but again, choosing your backend depends on team and complexity of the project. So for the very basic things, we say, okay, we're not going to program in Dart, we just use a Firebase, Superbase, because it can do so many things out of the box. But as soon as you need to start integrating a bit more with other systems, we say, okay, put a Dart Frog in between, and it gives a lot of flexibility. We had one case where we needed to integrate with another system. We started with Dart Frog. It appeared the other system wasn't performant enough, and without changing the app, we could just route the calls in our proxy layer in another way to first go to the caching layer. And serve the data with good response times. But of course, you have other types of backends as well. The heavy one, complex logics, and there we say, okay, then it becomes so big and so complex. There are much better backend frameworks than Dart, suitable for jobs like this, Java, .NET, etc. And then we stay focused most on the mobile app and have another specialized team focused on backend. So that's a bit, the different flavors which we see and how we deal with different types of mobile apps and backends. So we say, yeah, Dart in the backend is great because it really helps us to speed up. You're coding all day in Dart. You need to do some, for mobile, I mean, you need to do some stuff in the backend. You don't need to switch language, and it really helps us to speed up. So we say, no backend, great, sometimes. Backend as a service, really specific cases, helps us speed up a lot. We mostly go for the proxy approach now, because it gives us a lot of control, and also if there's complex systems behind, we like to control as a mobile team the backend layer where we interact with ourselves, but because it helps us speed up. So it's also a bit of a project approach, how to do your projects in a good way. And then, the last variant, I said, okay, the heavy backends where you have a dedicated team also on it. So key message, align your backend approach well with the project complexity and with your team capabilities. And if you can do Dart, then do it, because it's great. All right, thanks.
Yes. Eens kijken, okay, this goes here. And then we should have everything. Okay, great. We still have picture over there. Okay, great. And I'm also recording. I pressed the button. Cool. Hi guys, I'm gonna talk a bit about Leak Tracker. It's a package, or maybe let's first introduce myself. I'm also from Unlocked. I'm not gonna give the speech on what Unlocked does. Robert already gave that a little bit. I'm one of the developers over there. So I go around day to day and build apps. Web apps, desktop apps, a little bit of everything. And today I'm going to talk about Leak Tracker. It's a package that some of you might have come across in like your pub/spec log file that was added by other dependencies, maybe not. It's a package, you can find it on pubdev. It's built by tools.dart.dev, so the Dart guys, the Flutter guys. They're trying to add it to the dev tools as well, but it's still under construction. So what I'm going to show you is just a small bit of it that works for me right now for the use cases that I'm using. Eventually it will be a bit bigger, hopefully. It will also be included in the dev tools. But for now, I'm gonna show you guys how you can use this package in your unit testing to track some memory leaks. That's basically the concept. I have some code in here. This is some setup code. Is this readable for everyone? It's a horrible, I see some people, Okay, maybe if I put it a bit bigger, is that, I really need to work on like the contrasting and the different like nice colors, but didn't have time. I did have time to prepare the demo a bit, but anyway. So this is my Flutter test config. It's a file that you can add in the root of your test folder, where you can dabble a bit with like run configuration or how your test should be run. As you can see, wait, maybe I can do this. Yes, I can do this. So this bit, this is Alchemist. It's a package that we use for golden testing. It's not the focus of what I want to show you guys now. What I want to show you is this leak testing. This is all that I need in order to set up leak testing, memory testing in my tests. It's really small. I also need to add the package, but like everything, the instructions are over here. So like leak tracking overview, you can click through, you're in a GitHub, then you can go a bit deeper how to set up everything. So I'm not going to show everything, just go to the pubdev. So this is my test config. So let's now imagine that we have an application. We have an application that has a login screen. User can fill in email, passwords, then press login, then goes to the home screen because they're logged in or not, depends. But we have a happy case here. We're logged in, and everything of the login form should be disposed, so no memory leaks, right? But how can we test this? Well, in here I have some code as well. So on the left, yes, I have my password text field. It's the handler or the widget that I use in my login form. It's really basic. In here, it is a stateful widget. So that means I have some state in here. Most importantly, I have a text editing controller right here. Yeah, that's fantastic. That's an arrow. So I have it in here. I initialize it in my init state. Then I have, I can scroll in. Okay. I have a column which it should contain more stuff, but I stripped it out because like I don't need it for this example. But I don't clean it up, so I forgot to dispose my text editing controller. Bad. That's bad of me. In here I have then my test. It's a bigger test. It is a test widget. In here I pump an app. I just pump my entire app in here. And I get a Go router back, and I expect that I'm on the onboarding route because it's a bigger flow, it contains an onboarding. I have a block in there as well that I use to like go into different steps of my onboarding flow. So the user opens the app, is on the onboarding flow, and I just pump a couple of things and I go through the different screens. When I go through these screens, my password text field is disposed and my text editing controller isn't properly disposed. So now if I go to here, we can see this. Is this big enough? Because no, yeah, that's what I usually get from colleagues as well, that it's not big enough. So in here, is this better? It's okay, okay. So I basically here have the same test. I'm not going to show you, it's in the slides. If I run my tests, I also get a cow that keeps shouting stuff that I need to fix. But in here, so it says, hey, you have a leak here. In the text editing controller, in my test, the user should be able to go through the onboarding flow. Oh, shoot, I should have fixed that. I thought I fixed that. Maybe, oh yeah, I have this dispose here. I dispose my password controller. I go back. Yeah, failing test before fixing code. Yeah, I did that. But now my test passed and my memory leak is fixed as well. So that's basically, in a short presentation, how you can use Leak Tracker in your tests to help you with memory leaks. Yeah.
Can you see the impact of forgetting to dispose that controller?
I imagine you could. I also imagine that when the package is actually matured enough and included in the DevTools, I saw them talking about you being able to see what the impact is, what isn't disposed, what is disposed. Right now in my apps that I'm using, I don't really see it. So take it with a grain of salt, but it's always good to actually dispose of like leaky memories. That kind of stuff, yeah. Die mag.
You hear me? It doesn't work. Okay, hi. So in this lightning talk, I wanted to share one of the challenges we faced at Codica, which was the ability to transmit an API key that we build on a mobile app to a computer. So the title is long, but it says everything that we will learn today. Okay, so a quick intro. What is Codica? Codica is a startup that tries to improve and make mobile app development easier by having some automations, both on predefined components, which we assemble to have a big boilerplate, and AI agents that automate code-based modifications. So we have an open source library of components, but the CLI itself, which is the medium through which users use our tool, is proprietary, and we need an API key to use it. So we have, as mobile app developers, we have built a mobile application that allows users to create API keys to have access to the CLI. Oops, okay. And here comes the question. Normally, in regular SaaS projects, you will have the API key directly on the web, but we have it on our mobile app. So the question is, how do we transfer it from one to the other? So as I said here, we have the Codica app. Those are the programmers which use our tool, which is a CLI on their computer. Okay. I'm sorry in advance for the horrible diagram I'm going to show. But yeah, it should make my explanation easier to follow. So the user will start by requesting a new API key on the mobile phone. How does it work? Quick side note, we are going to use Firestore as database, which is shown on the top. So how does it work? The mobile app simply creates a new document in Firestore. This triggers a cloud function that will make the required verification to make sure that the user has actually access to it, and then we'll return the API key in Firestore. Of course, only that user has access to the API key in Firestore, and the reason the CLI doesn't have access is simply because we're not authenticated with Firebase in the CLI. Yeah, the user has access to the API key. So now, how are we supposed to transfer the key that we have here on the computer? We want to have something user-friendly so that people don't have to copy actually manually the key, which is quite long. And so we came up with a system with a QR code and a PIN code. So here, the encryption scheme, we need to talk about a bit of cryptography. So there is a really known encryption scheme which is called RSA, which allows actually someone to create two keys. I'm quickly going to explain the mechanism, but we have a public key and a secret key. The public key is shared to anyone and allow anyone to encrypt some data with the public key. And only the one that has the secret key can decipher the encryption. So our CLI will basically start by creating some key pairs and a request ID. It will send, so it will call actually an endpoint on our server, so a cloud function that will store the request inside Firestore, and will also send a PIN code back, which is a shorter version than the UID of the request. I'll come back later on how it works. What this means is that the CLI is now able to show a QR code that has a simple UID, the UID of the request, and that the user can scan with his phone. By scanning this, the user has access to the UID, which enables him to go in Firestore and get access to the public key. The reason we don't share the public key inside the QR code directly is because it's too long, and QR codes have some maximum size of data, so we bypass this. Now, the user has the public key, he has the API key. Using both, he will be able to create an encrypted version of the API key, which we will then store back
into Firestore. Now the CLI can have access to that key, and will simply use the secret key to decipher the encrypted version of the key and have access directly on the computer. So it's fairly easy said like this. In code, it's a bit more technical. To make something really robust, it's a lot of code and a lot of functions. And let me quickly, so demo time, let me quickly show how it works. So this is our CLI. It's called the whale. And inside the whale, do I have Wi-Fi? Yes. Inside whale, I can say whale configure. And here we can mention the Codica API key. We'll overwrite the existing one. So here we can see it created a QR code and also a PIN code. And I will show now, share my phone screen. Oops. Okay, wait. Since I need to scan, it won't work. Since I need to scan the QR code with my phone, I won't be able to do it, so I will use the PIN code. It's 81824. Okay. So this is the Codica app. We can create a new API key. I will use the PIN code. What was it? What was it? 81824. Continue. Oh, wait. Yes. So the PIN code has been validated. Now we can enter a new key name, create key. It generates the API key on the server. And now it synchronizes the key directly on my computer. And now if I go back here, we can see API key configured successfully. Okay, thank you very much for listening. Yes?
Do you want to make a package on how to show the QR code in the CLI?
I can show you right now, actually. It's really simple. It's simply tokens, actually. There are characters that define the shape. I'm going to show you library. I just need to find it back. Logger extension. Yes. So basically, it's just like this. Those are characters, and I need to compute exactly which one I want to show it. So I couldn't share the code because the lightning talk is like 5 minutes, but I'm really up to showing anything if there are questions right now. Also, side note, so Codica has open source blocks for authentication, geolocation that can easily be assembled. And the API key system entirely is one of the blocks that's open source in the Codica ecosystem. All right, thank you.
Event. It's really nice to see that such a community exists and also is very supportive. I often ask some questions in the Slack channel and most of the time they get answered, so it's really nice. And also from my role, it's really important if we choose for technology that it's technology that is active because we really bet on it. And it's 2 years ago that that guy here, Tijl, was like nagging like we need to try a new technology in mobile land. But that said, first, we are Lemon, so we are not from Kronos, as some asked the question. We are near to Kronos, but we are not. We're based in Antwerp, Ghent, and Leuven, and I had some questions. What do you do actually? It's very simple. We build mobile apps, but also web platforms and bigger applications with quite complex backends. We do that in 2 modes, very simple. In project modus, where we have an in-house agency. There also a Flutter team exists. We are like 20 people, 25. And the other team are our great consultants that share that knowledge at our customers. But I'm not going to showcase some apps during our presentation. Tijl will sneak peek some apps we built. But this year alone, we launched 6 mobile applications. And I think that's a nice accomplishment because they were quite big. So we are really like going forward with Flutter. But aside from that, we also still do other technologies like React and Angular, because we also still believe they're quite good, but for mobile, our way is Flutter. And Tijl will tell you how we transitioned from React Native, React Capacitor to Flutter. So Tijl,
all right.
Go ahead.
Okay. Hi, everyone. Okay, so hello. My name is Tijl, and I'm first going to ask some questions. Who here is a little bit new with Flutter, or is starting up? Like, okay, we have quite a people that are starting to learn Flutter. Okay, that's nice, that's nice. Who here has some knowledge about React? Okay. Nice. We have some people that know React. Okay, that's good, because that's what my talk is about. All right. Let me introduce myself. I'm Tijl. I am the mobile lead here at Lemon, starting with Flutter and everything that mobile related, because we like some mobile things over here. Lemon is already introduced. So let me get right into it. All right. So first, a little bit of a timeline here, because obviously, like we said, we started from React. How did that happen? Like a few years back, I started working here, and I started here as a React developer. I was doing web development in React, but we also needed some mobile applications over here. And then obviously a quite natural approach would be to start using React Native, because the technologies are quite similar in the way that they work. So we could quite easily transition to it. So we started developing projects in React Native. For example, we had Playas1 or E6. Those are some older projects that we built, and we built them using React Native. Then some clients came, for example, Linker, and they needed also web technology together with their mobile applications. And at the time, React Native, there was like a web version, but it didn't really do anything. So what we did, we built the application completely in React, the web version, and we just packaged it in Capacitor and shipped that to the stores, so we could have a mobile application in the stores and also use web technology. Okay, so we went a few months further, and I already went to a Flutter talk, and I heard a lot about this Flutter thing, and I really wanted to do something with it, because I heard a lot about it. I was like, wow, this is cool technology. I want to do something with it. And then a small project came our way. It was for the Slim's Demands. I think most people know it over here. It's the board game. They needed like a small timer app to companion the board game. So it was a small project, and we were like, okay, we're gonna try this in Flutter. So I had about 3 weeks where I was like learning Flutter and also building this application. It was a fairly easy thing because there was no backend involved. It was just some basic timers and only a few screens. So it was quite doable, not a lot of complexity involved. But I liked what I saw there with Flutter. We had this more intuitive way of building UIs instead of like using that dated HTML technology. We were now able to use these classes that were available in the Flutter ecosystem. I was like, okay, this is nice. I like where this is going, and also the app that came out of it was quite a polished application. I was like, okay, I like this technology. Okay, but now we had this technology, we liked it, but we also had a whole bunch of other developers that were used to develop in React, and we needed to spin it up because obviously I wasn't going to be able to build all this app alone. So we needed to shift some other developers. And we did it in a bigger project called Bvoy. But yeah, how we're gonna move everything over? We have a few things that we need to tackle first. The first thing is state management. Obviously, that's quite important for an application. And we had already had some equivalent for that in React. We could use the hooks, the use state. We could manage some state there. We also need to manage a global state that also had an equivalent in React. We could use the context provider. We also had a way to do network calls using the React query libraries or other similar libraries. Also responsive design, also quite important, but in web technology that's fairly easy to do. And we also need a way to deploy everything to test. All right, so we have these building blocks that we need to manage, that we need to finish. All right, how were we gonna tackle that? And then I stumbled upon this nice package that really solved my key to how we could transition from React to Flutter. And it's called Flutter hooks. Who here knows about Flutter hooks? Okay, quite a lot of people know about it. It's very nice, okay, right? This was really the bread and butter of how we were able to transition easily from React to Flutter. Because I was used to writing everything in React. I was used to using the use state, use effect, all this functional programming stuff. And when I was doing Flutter at first, all these classes and stateful and stateless widgets, I was like, I'm not used to this OOP stuff. Like, if you are good with it, continue doing it. But it was not my thing. So then I stumbled upon Flutter hooks, and I was like, okay, we can use this. So we started using that in our projects, and I want to show you a little bit. So we have, for example, for Fiberclad, we have this application where we also needed to manage a lot of states, a lot of forms, and we were able to do all of that functionally using these Flutter hooks. But for here, we have an example. It's just a basic React component. It has a button on it, and we can click on it, and it will increment the timer. I think most people over here will know what this application is, because everybody has started a Flutter project. And inside of this application, we have state. Let's start with useState to start on 0. That has the count with us. That is displayed inside of our UI. We have a function that will increase our count using this setCount function. And then we have a button that will call that function. Right, that's pretty functional. I think most people that know React will understand this code. Now, on the left here, I have the default demo project from Flutter. Like, I can quickly go over it. We have a state in our stateful widget, a function to increment our counter, and a way to display our counter, and we call it from our button, our increment function. All right, and now how we do that in our hook, or Flutter hooks. First, we extend a hook widget, which is just basically a stateless widget, but now it's a hook widget, but for the rest it's all the same. Everything happens inside of our build function. As you can see, I initialize this useState inside of the build function itself. I have this increment counter, and I can just call them both from the same UI. So now I can implement all of my functionality in a functional way inside of my build function. All right, so we have this, and I want to go over a few basic hooks that we have available inside Flutter hooks. The first four, I think, for the React developers should be quite recognizable. We have a state, an effect, a memoized, use reducer. Those are all hooks that are available inside of the Flutter hooks package. But we also have some other hooks, like a text editing controller or a listenable or other scroll controllers, and all these type of controllers. They're also exposed by the Flutter hooks package. For example, like if you want to have it memory safe, they are all automatically disposed. You don't have to do anything with it. That's a nice thing about it as well. But there are a lot of functions available to do this functional programming inside of our applications. Okay, that's the main thing tackled now. We can write this functional code with these hooks. We can manage our state. Now, how are we going to manage our global state? For that, we use Riverpod. I think most people over here know Riverpod. Who does not know Riverpod? Okay, a few person that does not know Riverpod. All right, okay, no worries. Riverpod is a global state management system. And it pairs very well with the Flutter hooks. If you go to the docs, there is also a toggle to show all the Flutter hook stuff inside of your docs. And also I have an example of that in React, where we have the context provider. On the left, we have our provider itself. This is a basic authentication. Obviously, this is not how we're going to use it in production, but this is just for demonstration purposes. We have an authentication provider with a state, whether a user is logged in or not, a login function, a register function, a logout function, and we can expose all that in a provider that we can wrap around our application. And inside, for example, a login page, we can access the provider, and we have some inputs there as well. We can call a function inside of our provider and get some results out of that. And that's all managed globally. Now we can do the same thing in Riverpod, where we create our auth notifier. We also have some functions in there. We also have a state in there. And we can also call that notifier from our page. And inside of our page, then we can call the functions that are on our provider, and we can actually easily log inside of our applications. For example, in this case, we also have these text editing controllers that are coming from our hooks that are implemented here in our UI. And then inside of our function, we just trim everything off. We get the result of our login, and then we can route everything to the right place. All right? So this is how we can manage our global state. Then another thing we need to tackle is our calls. Here at Lemon, we almost always use GraphQL because we build our own custom backends, and we like GraphQL because we have all the domain generation and everything that comes with it. So we use GraphQL Flutter. GraphQL Flutter is a very nice package. Who has used GraphQL Flutter here? Okay, quite a lot of people. Okay, nice. Okay, so GraphQL Flutter, what can it do? So first we have our basic stuff where it can do all the network calls. We have a lot of automatic generation. So we just write out our basic scheme. We write out our query just in GraphQL. And it will generate all the boilerplate Dart code to, for example, parse our JSON to Dart objects. But it will also generate all the hooks that we need to use this inside of our code. And it also has a lot of managing over our cache. To give you a bit of context about that, we have, I have built a fairly basic diagram about how this works, where we have a network layer. Obviously, we just do our calls to our network. But then we have a big cache that is spread throughout our entire application as like a big provider around our application, where we have all our hooks that we can attach to that provider, and we can call all of them from our code. And all these hooks expose a data, a loading state, and an error state, and some other things. But those are the main things. And from these states, we can just show our data directly to our users in a functional way. But why do we have this cache here, and why is it so handy to have it spread over our entire application? Another example here, we have Receptive Sandra, which was an app we built. It's a recipe app. And you have the option to like recipes inside of that application. And obviously, if you like a recipe, you don't want to show a spinner, refetch if it's done, blah, blah, blah. We want to do that optimistically. So because we have that shared cache there, we can just update our cache every time a recipe is liked. And everywhere in our application, the data will automatically update, and we can have instant feedback that a recipe was liked. You don't need to show those spinners or those type of stuff. All right, a little bit of code to showcase this. We have a hook that is automatically generated by our package that will fetch a user in this case. We can parse out the parse data. We have this available as an object that is completely a Dart object. It's not JSON anymore. We have a loading state, and we have an exception. Based on those states, we can show other UI elements. If our result is completely loaded, we can just display it to our user. We also have this profile equals null check here. That is because we want to use that cache, and every time a page is loaded, and we also already have something in our cache, the is loading will go to true. So normally, if we don't put it over there, the circular progress indicator will be shown, but there is something available in our cache, so we already want to show that to our users to have a more a more responsible UI for our users. Okay, so we have tackled the main things now. We could actually quite easily start a development process up with new developers. The only actual thing that you need to learn now for Flutter is the UI, because that is still completely different, but all the logic behind it, we can do it with the same paradigms that we are used to as React developers. I'm not saying everybody should use this, because some people have different backgrounds, but for a company that mainly has React developers, this is a very interesting way of implementing it. And I want to go over some other things as well, because we were used to web development, and web development has a lot of interesting features. For example, one of the main things is responsive design. All the projects that we do here at Lemon we also always use the web version of Flutter as well. So even if the client doesn't require a web version, we still build our UI with the web version just because we want to promise our clients, okay, our app will scale, it will be responsive. If you need to spin up all the other simulators every time to check whether it's available on all different screen sizes, because these days we have iPhone SEs that are very small, but we also have the foldables, the iPads. So we have a large range of different devices where our applications need to run. We really want that responsiveness in there. So that's where web development really comes in handy. And even though it's not always required, we try to build almost all of our UI inside of the web version and make all the functionality work in that web version as well, just because we want that ease of development that we got out of the browser. And as well, the deployments that come with that, because everybody knows deploying an app is a pain in the ass. Deploying a web app is a lot less a pain in the ass, because it's just a URL, and you can go to the URL, and some pipeline can just update the files on the server. And that's why we use Amplify hosting. Who here uses Vercel or knows what Vercel is? Quite a lot of people. Do you like it? Because it has a lot of interesting features. For example, on your pull request, it will automatically create a URL. Whenever you're reviewing something, you just click a URL, and then you can see what was done inside of that PR. Amplify hosting is almost the equivalent from Vercel, but then for AWS. So you can just let your clients charge it, and you don't need to worry about pay per user. So it's a nicer paying scheme. It was for us real easy to just spin up the web version, say, hey, everyone, every time we push domain, this is the branch, this is the URL, just check it out, and this is always the latest version you have, which is really easy if you want to test something and not always deploy a new application. Then I want to go quickly over our project structure. We have the lib folder, I think everyone knows that. Then we have a folder that contains all of our common widgets, like, for example, buttons, inputs, whatever the fuck. Then we have a config file folder where we store all of our config functions, an environment for, variable folder where we store all of our environment variables. We actually use enved for that, so we have a .env file somewhere else in our file system, and we just build it during with the builder, as you know it, and it will just generate a scrambled version of these environment variables to have it more securely inside of your applications. Then we have the main thing. It's in our features folder. We split everything up in different features. For example, we have our login, and inside of our login we have our different, we have our authentication, and we have our different login features there. They all have their separate folder, and inside every folder is mainly a page. We have our main page widget in there as well, but we have also actions and queries and all our side widgets that come with that feature. All the query stuff, it's all the functions that we need to query. This can be all the network calls, but also, for example, if you need the state of the camera or the location of whatever. Then we have the actions. Actions, it really fits to our CQRS approach, because when we build our applications in our backend, we use CQRS to manage the state. So we have the mutations and the queries, and we can easily see that in our frontend as well. We have the actions, which is someone clicks a button or something, everything needs to happen. We store all this function for that in the designated folders. Then we have our providers, where we store all our global state for our river pod. The infrastructure folder, this is mainly there for testing, where we can store like config files or functions to expose the camera or the location and those kind of stuff. The routes, we use autorouter for that. The themes speak for itself. Translations, we use easy localizations just because we could just, during runtime, update all the translations if we want. We don't need to do a new deploy for that. And then a utils folder as well. All right, then we come to testing. For example, we have the Olympus Mobility app. That was quite a complex application, so we need to do a lot of testing inside of that application. And there we use BDD. There was already a lightning talk about BDD, so I'm not going to go into depth about that. But BDD, shortly, what is it? We can write out a BDD file like this, where we just describe in human language whatever needs to happen or what needs to be tested inside of our applications. Business should also be able to read these files, and everybody should be able to understand what is going on here. All these sentences you see over here, they all get translated to tests, Dart tests. And you also have like some variables in here that can easily be changed. And for example, we have a way to say, I press this button. All our buttons inside of our applications have their unique keys. And if we go to another page, I mean, you need to write tests for that page, we only need to write out this file, and most functionality will already be implemented, so we can easily implement new tests. So this is also something we use in React, and it was also nice to have this available in Flutter. All right, then the last thing, we need to go live. We have our deployments, where we use CodeMagic. I think almost everybody knows here CodeMagic. Who doesn't know CodeMagic? No? Okay, very nice tool to have for your pipelines to deploy all your applications. Our main, or like our test builds, they all go to a Firebase app distribute, because it's just easy. We have all of our iPhones that we have in turn here at Lemon. They are all registered at Apple, so we can just distribute it easily. But for our clients, it's not always easy to have that Firebase, because they're always like, oh, I don't understand it, how I should register my device. So it's always a pain in the ass, so that's why we use TestFlight. We also have Shorebird. If you don't use Shorebird, also just enable it in your applications. It's very nice to be able to push something to an app that is already in production without going to the entire app process. So it's easy to push bugs. Then we have our different flavors, because we want to have different apps installed during the development. So we can just have a flavor for staging, for dev, and for production, and we can just all install them at the same time. I already talked about Amplify hosting. Here you can see how it will look inside of your PRs. You just click the link. And then as last thing, we have Datadog, which is our monitoring tool, which just gives us a nice dashboard where we can view all the things that are happening inside of our applications. All right, that was me going over how we at Lemon do our Flutter setup and how we came from a React thing. Don't take this as the golden approach, but definitely an interesting way of doing it if you're coming from a React background. All right, are there any questions left?
Like in React, we use normally MUI or Chakra UI or something like that. So how can we support the Flutter, or what are the tools we can use?
Yes, so what I was mainly talking about is the state management of React. And yeah, if you are used to Material UI, that's obviously inside of Flutter, because yeah, it's all built by Google. There are some UI libraries that have some pre-built widgets for Flutter, but yeah, you are still stuck to how we build UI inside Flutter. It's not like you can use these HTML paradigms. Always somebody knows about it, tell me, but I don't know any way of writing HTML code, and have it translated to Dart. Okay.
Have you considered maybe contributing to the Flutter hooks package and implement some more modern React hooks, like the use optimistic hook, because that could help you?
Yeah,
on
I was
caching,
just,
for example.
actually today we had a new hook, that was Mathieu was implementing it, where I had some other controllers that also needs to be implemented, and I was thinking, okay, maybe we should contribute that in the future, but right now we didn't have any real new hooks that were worthy of contributing yet, but coming up. All right, yeah?
I think this more functional approach is not common to all Flutter developers. How do they react when they join the team and come from a different background?
Well, we didn't have that yet here at Lemon, because everybody that started here started or with no knowledge at all or with React knowledge. So it was for us the most logical approach to do that. And also if we have new hires, because you know, the Flutter community, it's not that big yet, if we look at like what's available there. And like, obviously here we are, but if we're gonna hire some people, yeah, it's also nice to have that React capability, because we are still building web versions of our applications, and we still believe that React is a good framework to build web applications. We do have some web applications that we built in Flutter, but that's only a companion app. If you need that SEO or everything else, we still go to React. And then it's easy that our developers can switch between the two things, all right?
So this summer I was an intern here, and I came from the classical Flutter training where you do a lot of OOP inheritance. It was quite jarring to not see any of that done here, but it also felt more natural. Functional widgets are also, they are more testable by nature. You do not need to mock some stuff that you need to usually mock. The only thing that's really weird is the control flow in the beginning, because you are defining your functions inside your build function. So it's sometimes really weird to see, but once you realize you can work with closures, it becomes actually, I think, even better. It's my opinion. I really like it a lot more of the OOP stuff.
I think it depends on really what you want. If you're really into OOP, I can understand it, but it's just another way of doing it. All right, yeah?
Have you noticed any performance downsides to doing it
Not
like this?
really, actually.
Just thinking back to the early React days, I think they would say not to do this approach,
Yeah.
because you would always refine your functions. I don't know how this works in Dart, but
Well, actually, behind it is using value notifiers. So for every state, it's just a value notifier. I don't really see any performance dips there. Obviously, all the pitfalls that are common in React still exist here, because we're still using the same paradigms. For example, sometimes there are states that are redefined using true use effect, and it's still, you need to be able to think about what is actually state and what is derived state. And that is still a pitfall you can easily see, but I think that is also the case in class-based programming. But it's definitely more pronounced here with hooks. But it's not like the hassles are different than from React. So if you know it in one place, you can actually really easily do that as well in the other place. All right?
Yes. Are you considering migrating apps which you built before in React Native and moving them to Flutter? Or?
Yes. Yes, we already did that for one application, but which was like the main application that we were still supporting, because most of we already do it for like more than 2 years now. We build all our new applications in Flutter, and we already have one major application that we're still maintaining in React Native, which was not that maintainable anymore. We completely moved that over to Flutter, and now it works a lot better. So we are really pleased with that. If you have questions about it, ask Ace. He knows everything about it. Yes, all right. Okay.
Did it work a lot better because it's Flutter, or because it was a rewrite and you did things cleaner?
Both, yeah. It was not the best React Native app as well, but yeah, we all want to shift it to the same paradigm, so it was easy to have that, and definitely the result that came out of it is a lot better. Okay.
Yeah. Because you used both React Native a lot and Flutter, what do you see as the main benefits?
So Flutter, it's not using the Node engine behind of it. So we get that performance boost out of there. I actually don't like the native approach that is React Native is taking, because it's still building a native UI. There are people that take this as an advantage, some take it as a disadvantage. It's an opinion, but I like it that we have our own render engine and we can really control all the pixels. And I find the way of structuring our UI with these classes a more logical approach than was available in React Native or React. Okay. Right. Any other questions? Yes.
You mentioned you use GraphQL and all the generation involved for the classes.
Yes.
I suppose you can't use it to push back to invoke changes on the backend. So do you also mock have those classes generated?
What do you mean with invoke?
GraphQL, I'm not very aware, but is it just reading?
No. So we have the queries and the mutations, and we also write out the mutations. So if I go back to my overview here, we have the queries and we have the mutations as well. They also generate their own hooks that we can just call. So we have a run function or whatever you call the function, that you just call it asynchronously and it will do everything. Right? There was another question.
Yeah, you mentioned something about you always test in web.
Yeah, we build our UI in web. Yeah.
What I always use is I always build my app into a macOS version, which I think the hot reloads were better, and then you can also make your screen bigger and smaller.
That's also an approach. I like the web version because we still have the network calls there directly from it, and we are used to all these tools there. I would say the hot reload works quite well in web. I didn't really have any issues with it. But I think indeed that's also another approach, but I really like that flexibility to have that responsiveness for our applications. Yes?
Mentioning web, didn't you run into limitations with packages which you need on mobile,
Yes.
not having sufficient support on web?
Yeah, we definitely have run into those issues. Then it's just a case web if statement. And sometimes we have applications that don't require the web version. And then we just say, okay, flat out, this function we're not going to implement because it's some really obscure logic that is only some edge case at the end of a flow. We can just not implement it in web, but we can view our UI in it. So mostly we write some other function around it for web that will just show the UI so we can actually test the UI itself, but not the full functionality that we can test on our mobile devices. Okay?
In React Native, when we have to get a simulator kind for Windows if you use Windows or iOS. So does the Flutter also does the same thing? Like it gives you a simulator when we are developing an app, or do we need extra devices to connect to a mobile to see our app which we are developing?
Are you talking about the Expo app? Yeah, there is no such thing as an Expo app if someone knows about an equivalent of Expo, but not to my knowledge. So it's just directly plugging it in. I would say I use VS Code as my editor, and it's really nice. Just plug it in, it shows up as a device, and you just click play, and everything runs. And for me, that's working really nice. Yeah, you can just write, there is like a command. And we also built that inside of our pipelines using CodeMagic to have all the signing there and upload it directly to Firebase. So if we have a version available, we just click a button and it will automatically build it and notify all of our testers directly on their phones. All right, any other questions? No? I think it's time for a break then? All right, okay. Right, thank you. 15 minutes. All right, 15-minute break.
Dus. Beginnen of... All right. Settle down. Hello. Ik ben al dicht aan het lopen. En nu? All right. Hello, everyone. So here. Hello, everyone. I lost my thingy, so I'm going to walk up and down. But I saw it has tracking, so it's very cool. Awesome. So we're going to test that out. My name is William. I'm a Flutter lead and AI domain lead at ICAPS. So what that means is I do things with Flutter and with AI. And today I'm going to combine the two of them. I've worked on apps like the COVID Safe, Ampere, Cybels, Blue Bike, and my passion, if you know me, you know what comes next, is for efficiency, animations, and I like shaders. But today I'm not going to talk about shaders, I'm going to talk about machine learning. And I think the most common thing you hear from machine learning is hard, it's a lot of math, and I'm here to tell you that's not true. It's not hard and it's not, well, it is math, but people a lot smarter than us, or at least a lot smarter than me, wrote packages for it, wrote plugins that does all this nice math and does it for us. So we can take that math and, I don't know where the bin is, but throw it away, we don't need it. The second step is to go to the trash, because we're actually going to need a bit of math. But it's not that hard. You'll need to know, things like a pixel. A pixel has 3 values. It's RGB. It's a range between 0 and 255. So if you want to use that for machine learning, you're going to input a value between 0 and 1. So you need to, for each pixel, you need to divide it by 255 and then have 3 inputs for each pixel. But that's most of the complicated stuff that we're going to do today. So you can relax. First, I'm going to talk a little bit about what is machine learning. I'm going to keep it brief. I assume most people know this or that about it, but it's also not that important. You have 3 types of machine learning. You have the supervised learning. Supervised learning is for when you have the data and you know what that data means. So let's say we want to determine a color and what name that color has. So then we have a whole list of RGB values and a whole list of this is blue, this is black, this is light green, this is that. And then, so you have the data and you have the labels. Unsupervised learning is when you have the data, but you don't have the labels. And an example of that is anomaly detection, let's say. So for example, we're looking at our server and we're seeing our server memory usage like this, and then it goes down and then it goes back up. We want to detect those things, so you can hard code if it's lower than a certain threshold, then we have an issue. But it might just simmer down at night, so you don't know what value it needs to be. You can use machine learning for that, and then you just input your history. You say, this is all fine data, it was up and running just fine, and then the machine learning algorithm will just determine itself. I see a spike, this was not in my training data, this is not normal, this is an anomaly. And then you can use that for an automated system and have a human look at it. So that's unsupervised. But what if we don't have any data and we don't have any labels? Then we're going to use reinforcement learning. Of course, you'll need something, and for reinforcement learning, you'll need the rule set. A big example is the game of battleships, Zeeslag. You have the rule set, I say a number, it says hit, miss, and you want to defeat the opponent. So that is something we can do with reinforcement learning. I actually did it for my bachelor paper, so if you're ever interested, come find me. But today we're only going to look into supervised learning, even though the others are perfectly capable of running on Flutter as well. And then there's this thing. If you're talking about machine learning, almost all of the time we're talking about neural networks, especially today. They go a lot bigger than this one. This is a very tiny one. But what this is not how it looks, but a visual representation of it. So you have your inputs. Those are the values we give to the model. So this is a model, a neural net, a model, whatever. These are the values we set, and then we have an output, and that's the value we get. For example, for our color determination model, we will have 3 inputs, one red, one blue, one green. And those will have values between 0 and 1. We'll set it, and then these are all calculations, and those are determined by the model itself. And then we'll get an output. If we're talking about colors, we'll have many outputs. That's a classification model. It will have, let's say, 21 outputs. So one for red, one for green, one for blue, one for light green, one for black. Those will be all the outputs, and those will all have values between 0 and 1. And then you just look at the outputs, say which is the biggest. Oh, that's the color it's going to be. And then the middle part is all the math. We're not interested in that. We just say the model, these are the labels, this is the data, figure out how this works. So this is normally what we write, but here it's done automatically. We have no idea. This is when people talk about a black box, is those values. Even if you look at them, you're not going to know, oh, now it's detecting a monkey. No, we have no idea. You can do some special stuff to visualize it, but it's not important most of the time. So I just mentioned classification. That's if we're doing colors. We can do object detection. The most famous one is faces. Where is an image? In this image, where is the person? The camera is doing this exactly right now. Where is the person? Oh, it's there. He's no longer in the center. I have to turn the camera like that. And then the last one, segmentation, is a bit more advanced than object detection. It's looking at every pixel and determining what category that pixel is related to. So if you look at a face, for example, you get a picture of a face, you put it in the model, and out will come the same face, but all black, and then the eyes, for example, will be marked. Those are eyes. You can do a lot with segmentation, and yeah, with all of these, and those are the ones I'm going to talk to you today. So we're actually going to train a classification model tonight, very exciting, if everything goes right. I already trained an object detection and already trained a segmentation model, but the code I will go through and we'll see what fun things we can do with it. And then we're obviously going to implement it into Flutter as well. So that's what we're going to do. We're going to start, of course, with the machine learning model, and we're going to go through 7 steps together. After this, 5 more steps to implement it in Flutter itself, and these are the steps. So first, we're going to install required libraries. Very exciting. I can't wait. And then we're going to load and validate the data set, create a model, train it, evaluate it, look at it ourselves, very important, and then save it so we can use it in an app. So, libraries. Again, very exciting. Those are the libraries. I'm not going to go through them right now. The last one is the most important one for today, because that's what I'm going to use, and then you can see it right here. This is Jupyter Notebook, and Jupyter Notebook is a way of executing code in blocks. So this is here a Python line, this is Python, and between those I've put Markdown so you can actually know what's going on. And if I go through here, for example, this is not going to do anything, but if I run it, only this piece of code ran. Very useful if you're developing, for example, machine learning, and you want to run a specific part of your code multiple times. For example, I've trained a model, but then I had an error in visualizing my history. I'm not going to go through training the whole model again. It can take days sometimes. I just want to keep the results I had previously and then executing only a small part of my code. And this, I'm going to go through this script today, and it's the color recognizer script. So this will be recognizing colors. Yeah, importing, I'm going to write my model and train it in Python. So importing in Python is very easy to read. It's very similar. Sometimes you'll see S. It's the same as in Dart. Yeah, not important. Step 1, load the dataset. So now we're actually talking about something useful. Sources of datasets. Obviously, if you're working for a company, you can't just download something from the internet and use it. You can do, for example, YOLO has several fun datasets, but there's also a license, which I don't fully trust. So usually I go to Kaggle. Kaggle is an online platform which has a lot of datasets, which has competitions for machine learning, and then you can download those datasets for other means as well. But most of the time, if you're actually doing something new, you will use a custom dataset. What does a dataset look like? This is, for example, a CSV file, which will have 3 values RGB, and then the label, which is the thing we're trying to learn, which we're trying to guess. That will be the category. So, for example, the first one, 255, it's a red, yeah, we know it's a red color, so that will be the first index, it's red. The second one, 251, it's also going to look very red. The third one, it's also going to look very red. So that's all red. Then the next line is green, and this will have 10,000 lines like this, which will have labels 0, 1, 2, 3, 4, 5, 6, up to 20. And we're going to load this CSV in, and then we're going to pre-process it. Pre-processing is very important. You're not just going to give your model 255. Usually you want to give it a value between 0 and 1 that will bring the best results. So pre-processing this will be divided by 255. That's the difficult math that I've shown you earlier. Sometimes if you don't have enough data or your model is a bit overfitting, you might want to augment it. Augment will mean use existing data, alter it a little bit, and then use that as an input. For example, if you have an image for a chair and you want to detect whether or not that's a chair, you can flip it horizontally. It will still be a chair. If you flip it vertically, it might not be a chair anymore. That's augmentation. And yeah, obviously resizing. If you have your model defined, you will define how many input fields this has. So if you have a model and we're going to say we have an image size of 640 by 640, then you'll have 640 times 640 times 3 inputs, and you'll need to provide all of those inputs every time. So if you have images that are not 640 by 640, those will not fit into the model input. So you're going to resize every image to be 640 by 640. And then pre-processing output, also important. If you just say 0, 1, 2, 3, and you assume that's the output, you're going to have a bad time because, between 19 and 20 is a very small gap, much smaller than between 0 and 1. You might say, no, it's just the 1. But if you think about how the model operates, it uses multiplication a lot, so it will be a lot closer together the bigger the numbers are. So what we're going to do is one-hot encode. That's just a fancy term to say 0 will be 1, 0, 0, 0, 0, 0. 1 will be 0, 1, 0, 0, 0, 0. So all zeros, and then the index, this will be the index of the 1 in the list. And then last is splitting the data. So you can have a long list, but you don't want to use the data it trained on to validate how well it's doing, because it's trained on that data. It knows that data. So if you remember in school, fun times, if you had time to prepare for a test and you saw 1 times 1 is 1, 1 times 2 is 2, and then you had the test, and the test will say 1 times 1 equals how much? yeah, then you're just remembering it. That's not learning multiplication. So the test will be 2 times 2, for example. Then you really have to think. And that's what we're trying to test as well here. So now I'm going to go through those first steps in the code. So very exciting setup, import, drum ruffle, will it work? It's taking a long time, you can see. Oh, yes, importing works. That was the easy part. Very scary, yeah. The curse of the demo, but it's working fine up until now. And then the first thing you'll see here is configuration and hyperparameters. So what that means is, the number of inputs. I want to say RGB, red, green, blue. So we'll have 3 inputs. And I also put it next in there in comments what those values are. Batch size is, for example, a hyperparameter. That means that if I change those parameters, the training might change a bit. So if it's not working right, we'll change the hyperparameters, and those are the batch size, the learning rate, how many epochs there are, stuff like that. And then I've got a little bit of config. For example, the model version, it's important that we train something, we can run it back. If we make a mistake, we don't lose the first version. And then here below is a little bit of cheating I did, because I don't have the actual data set of 100,000 lines. I didn't go through and mark them one by one. I have a list of all the colors I want to detect and their RGB values. And then later on, we're going to create our data set. This is not something you should do. If you're planning on machine learning, if you're going to generate the labels, then just use that formula to determine the outcome instead of training a model. But I will also show you what the drawbacks are by doing it like this. So right now we're going to train it. I'm quickly going to disable this, and then we'll notice a small issue. And here is the first step that I find important, and that's validating. Validating stuff that you do. It's very important in machine learning, and after each step you will see that I'm validating something. So right now we're loading our data, and then we're going to validate, is the data fine? Can we use it? So what is important when doing stuff like this is that your distribution is fine. So if I look at this list, I can see, for example, gray is very high represented. 14% of all our stuff is gray. But then if I look, and I really have to look over here, yellow, you see that only 0.32% is yellow. So if you're going to train with this data set, it might just always say gray. Why? Because it's going to be right 14.5% of the time. And you have to look at machine learning as something very lazy. If it can find a quick workaround, if it can do something easy, it's going to do that. So it's never going to guess yellow, because it's always going to be incorrect. It's always going to be brown or gray or stuff like that. So what we want to do is we want to use either data augmentation or go back into the real world and take some more pictures. But today we're not going to do that, because why would we? And then here you can see I have yellow, amber, and orange, and I want to generate more values for those. And then if we now run it again, we're going to have to wait another 20 seconds. But then you'll see here that the distribution is much, much better. And now you can also see the power of Jupyter. I don't need to import again. We saved the whole 7 seconds, if I remember correctly. No, I ran it again, so we already lost it, but no worries. And here you can see, before we look at that, the training and validation split as well. Right now I've got 87,000 training samples and 12,500 test samples. I'm more going to do validation with those, but let's ignore the semantics. This is a good representation. most of the time you're going to use 10 to 20% for training, for testing and validation. It depends on your results. You can change that where needed. It also depends on your data set. So now we can see gray is still 13%, but we can also see yellow, if I find it again, we're already at 3%. Right, nice. So now it's also going to guess yellow sometimes, and it might be wrong sometimes, and it might be right sometimes. But at least it's going to guess that. Some more configuration needed. This is just, splitting it up, getting the values right, and this is here where we're going to use our training data and put it in a batch, in batches, so that we can train on those. You'll see here the batch size. That's important. That's how many pieces of data the model is going to look at. So you can do a batch size of 1, and then it's going to go through each and every line of your data, or you can increase the batch size, make it faster, so you don't have to wait that long, but it will use more data. We're also going to shuffle our data. Why is that needed? If you have a data set, most often it's going to be, like I mentioned here, first all the reds, then all the greens, then all the blues. It's not good for your model, because then it will first start to guess red on everything, then it will start to guess green on everything, instead of actually learning something. So again, if it's lazy, it's going to start to use workarounds. So that's why we always shuffle it. You'll also see the seed here. The seed is just used for so you can have the same results every time, and it doesn't matter at all what you put there. It just needs to be a value. You can put it to anything you will like. All right, now we have our training batches, and then again, we loaded our data. We're going to validate it. What we're going to validate right now is to see if our labels are correctly interpreted and to the correct data. So if I run this code over here, you can see lime. That's very obviously lime. And then you'll see green. So is this now correct? No, because that's not lime. Oh no, everything failed. Well, no, that's the result of our generating data. Every human will see that this is not lime, but we generated the data using a method, and it will just be checking which color is closest. So we'll see some strange results later on as well. This is not lime. That's what we're trying to automate. So we would put a human in the loop, and he will label everything, and then he will label this correctly. That is not lime. Over here, it's better, light green. That's light green. You look at your distribution, and you validate that it is balanced, and you check, of course, that everything is loaded correctly. If we're talking about, for example, object detection, you're also going to verify that the bounding box in your data is around the face. First time I ran the loading in the data of the object detection, and the face was not here, but it was here. So then I already knew, if I continue with this, it's not going to work. So that's very important. Step 2 is define the model. And this is the hard part. We're now creating a neural network. This is one of the easiest models you'll ever see. We have our input layer, we have our output layer, and we connect them. That's awesome. So how does that look? That looks like this. So these are our RGB values. These are our 21 outputs. And this is a whole lot of math. And this one, you might say that's not an input. That's our bias. It's used inside the model. How it's actually doing it is, for example, the first color is going to take this value, multiply it by minus 2.6, minus 0.26, then plus this value times some value, plus this value times some value, plus this value. That's the difficult maths that we don't care about. We're going to put our input in it. We're going to get an output, and then we're going to say this is right or this is wrong. If we say this is right, it will enforce the correct weights and biases. If it's wrong, it will unenforce or enforce different ones here. So those values will shift every time we learn just a little bit. We're now using a learning rate of 0.1. If I go up here, you'll see we're using a learning rate of 0.1, but I've used values of 0.00001. So it's really slowly learning, and it takes a long time, but that's more often better to get a better result. All right, so create the model, the same code here. So input layer, output layer, connect the two, and we're going to get a model, and we return it. And then the next step is compiling the model. And compiling the model sounds a bit difficult. We're going to choose a loss function, an optimizer, and metrics. Those are all very difficult terms. Optimizer, just Google it. I'm trying to do this. What's a good optimizer? Oh, Adam. Adam is always fun. We're going to use Adam. OK, good. I want to categorize something. What's a good loss function? Well, category cross entropy. What is this? This is difficult maths I don't understand. But we don't need to understand it. That's the beauty. Somebody else wrote it. It's already optimized. It works fine. We're just going to use it. And this here is actually how the loss function and the optimizer work together to get the best output. So here, this is just a 2D representation. This is one variable. This is another variable. And then the value above is the output of a loss function. So how this is calculated, it can be anything. It's Adam that calculates it. So we don't know it's the categorical cross entropy that calculates the values. We don't really care. But what you see is, for example, this has a very high loss. That means it has a bad result. So the loss is how bad or how good the model is. And this value here is very bad. So we want to get away from it. And then if you have this 2D matrix, you'll see that the optimizer will see, oh, we are at this slope. We have a fancy math terms. We're going to go this way. And so we repeat that every training, and then you'll see it slowly goes down, now. And for example here, this is a local optimum. That's very important to avoid. If we have a very low learning rate, it will go into it, and it won't ever get out of it. It will be stuck there, because that's a local optima. That's a local place where it works the best. It has the best output. So you'll need to choose a bit better output, a better learning rate. But if we choose a too high learning rate, it will go here. Then it will go around and around and around and around, but never go in. So how do we solve that? We can do, I don't know if it's on that slide. No. We can do a learning rate. We can change it after a few times. So we can say after 10 times, we're going to lower the learning rate a little bit. And then we're going to lower it again. So then it's going to fast find the global optimum and then go deep into the hole as we would like. You might say, well, this is very easy. I can see it here. Here, this is the best one. Pick this one. As I mentioned, 2 variables. Machine learning, for the face detection, I think we're talking about 2 million variables. I can see 2D, I can see 3D, I can't see 2 million D. If you can see 2 million D, please raise your hand. That would be awesome. But yeah, it's harder than this representation, of course. Don't mind the spelling errors. So we're going to take the input and the output of the data set. We're going to put the input through the model, and we're going to get a prediction. So we're going to compile the model. We're going to run a prediction, and then this is what we get. So this is the color we input. This is the label we input, and these are all the predictions. So you might say, hey, we didn't learn anything, and the output is very bad. Well, yeah, we didn't learn anything yet. But we're just trying to visualize, is this working? Can we put our input into the model? And do we get an output we expect? So what do we expect the first time when it's untrained to be the values? all in the same range. So here you can see they're all between 0.02 and 0.06, which is good. This is what we like to see now. Later on, we want to see, for example, green here. Green has to be very high, near to 1, and all the rest needs to be near to 0. So now that we have this verified, we can put it in a callback, and then when we're training the model, every time it went to the whole data set, we can visualize what it's doing right now. Very cool. We're almost there. Training the model. So this is the most important, exciting part. We're actually going to train a model right now. So for this model, I've had 16 of a batch size. So we're going to input 16 data points at the same time. And we're going to use a learning rate of 0.1. And then we're going to do it 10 times with the whole data set. All right, let's go. Right now, you can see it's doing something. Here you can see the loss. Here you can see the loss. And here you can see a metric we defined. That's the mean square error. That's not important how it's calculated, but what is important is that we expect both values to go down. And now you're seeing this value is going down. And every time it went through the whole data set, you'll see here, it's going to predict it, and it's getting better and better. So every time it's more in the green and less in the teal, and all the rest is already 0. So we're going 10 times through the whole data set. Remember, 100,000 colors. 10 times is 1,000,000 times running the model, but it's already done. Awesome. So what did it learn? Well, it's now predicting for this input almost completely green and a little bit of teal. So we're just going to take the highest value here, and we're going to say, yeah, this is green. Let's check the data set. Yeah, it says green, so it learned something. Awesome. That's just in case everything broke. So now that we learned, we're going to check, did we do something good or did we do something bad? And how we can do that is just by taking the loss and then the validation loss and plotting them on an axis. And I'm going to remove this line and make it better. All right, and this is what we get. So what we see here is the validation loss. Those are the points. And then the training loss, that's the red line. So the loss on the training data set went down, and the loss on the validation data set stayed the same. This is bad. Not a good model. We did something wrong, and what we did wrong is we used the bad data set. So we're not going to get much better than this. But what we do see is that it's not high, it's not going up, so it's not the worst. This is from last week when I trained the model. What you see here is the validation loss getting higher and higher, and the training accuracy went up, but the training accuracy, the validation accuracy stayed near 0. So this was very bad, and that's called overfitting. So what it did, it remembered what we learned during our class. It remembered 1 times 1 is 1, 1 times 2 is 2, and it learned that out of its head and forgot everything else that is possible. So it's a very bad model. If you say 2 times 2, it will say 2, because it's either 1 or 2. That's what I learned. The rest is not possible. That's what we would want to avoid. This is also not that great, but again, we have a bad data set. If we're going to look through the other trainings I did, you're going to see a much nicer decrease. So if you encounter this, what you do is you get more data. That's never possible almost. So you're going to adjust your hyperparameters, maybe a lower learning rate. You might add more data augmentation and do stuff like that. But then you train your model, and the next step is evaluate it manually. So what you can do is you can go the boring route and just take your test colors and then see what the output is. But we're not doing the boring route today. Today we're using it in Flutter. So right into the presentation, we can say red 255, green and blue 0. What is the output? This is how it looks. And this is 100% red. Yes, success. If we add green, we're going to get yellow. Maybe a little bit of amber, but it's pretty sure that it's yellow. If we're going to add blue, then we'll see white, and it's white. Very awesome. So I now manually verified the model is very good. I can ship it. We're done here. Yeah. No, that was just the happy flow. We're now going to check the unhappy flow. And for example, if I lower this one, we can lower it all the way halfway here. This is no longer white. It's sure that it's white, but this is no longer white. This is pink for me. What happened is our data set has a value for pink and a value for pink. You can see it here. That's not pink. It is pink, but it's not the only pink you have. So what happened was that our data set is bad, and it set for this point, higher than 1 to 8, is going to be white because it's closer to white. So in practice, test it, validate it, and make sure a human made the data set and not just a formula, because you'll get the output of the formula. Some other fun stuff, yeah, this one says gray or indigo. If we lower this, obviously it's going to be gray. If we put less of this, it's going to be purple. And yeah, it says deep purple, that's good. If we lower it more, it's going to be purple. If we're trying to, yeah, this is purple, nice. So we can play around with it. Most of the time it's going to be good. If we're around gray or around white, it might be a little bit funky. But yeah, for example, this one, deep orange, that's pretty good. If you look at it, it's closest to the deep orange and further away from orange itself. All right, awesome. Very important, don't forget to save. If you close everything down and you lose your session, you lose your model and you have to retrain it. Now it's just a few seconds, but it can take a few hours to days. So this is important. Usually you'll save as a Keras file nowadays. H5 is deprecated, but it's similar. If you save it as Keras or H5, you can train further, train again. You can also save it as a TF Lite, and then you can use it in your app in Flutter. So I often save both, just in case, so we can always train again if we need it. And you'll also notice, it's not in this one, but you'll notice here that we have callbacks. And one thing I like to put in a callback is saving in between epochs. So you'll see it later on. It's going to save every time we do an epoch, and it's better value than the last one, then we're going to save it. So yeah, some tips. Quality of data, very important. They always say shit in, shit out. You saw it today. So data quality, very important. Data relevance is also important. It's going to use all of the inputs to try and guess the output. If you put RGB in, and then you also put in the time of day, it's going to try to use the time of day to guess the color. But that doesn't matter, except if everyone only puts in black when it's night. But most of the time, it's not going to matter, so that's very important. It will use the time of day to guess the answer, and if you, for any reason, have all the training data be light when it's day and dark when it's night, then it's always going to do that. A fun story about that is wolf or dog. They trained a whole model to guess if a picture contains a dog or a wolf. It was very good. It had a pretty nice accuracy. Then they put it in production, and then they saw a lot of people saying, hey, my dog is marked as a wolf. And then they looked at their training data, and they saw that all of their training data contained wolves in snow and dogs not in snow. So what the model did was not determine, is this a dog or a wolf? It just saw, oh, there's white on this picture, it's going to be a wolf. Again, all of the previous steps, validate is very important. A better approach would then be to segment the dog or the wolf, so you only have that, or just have more data of wolves not being in the slow and dogs being in the slow. So validate after each step. I find that very important. And then the last one, versions are important. If you're going to do this, use virtual environment. This is kind of FVM for Python. The main difference is in Python, everything is global. All your packages are global. So if you train using TensorFlow 2.15, another project that you use TensorFlow will also use 2.15. Why is that important? In our case, because TensorFlow 2.16 gave me errors in Flutter, 2.15 worked, so make sure you're using correct versions. And if you're going to do multiple things with Python, use virtual environment. All right, now that I bored almost everyone to death, we're actually going to talk about Flutter. Flutter and machine learning together, how difficult will it be? Well, 5 steps. We're going to install all the required libraries. It's just the one, just dflight Flutter. Then we're going to load them all. It's going to be very easy. Then we're going to pre-process our input. That depends on how difficult it was in your model. Then we're going to run inference, which just means predicting it. And then we're going to handle our output, which also depends on how difficult your model is. So here I mentioned version is important. dflight Flutter, the latest version doesn't work for me. The 10.4 works with TensorFlow 2.15. So you kind of have to look at what versions work together. And web is not supported. They say it's because it's implemented per platform, and web uses JavaScript, and it's not working with JavaScript for some reason. There is a dflight for JavaScript, but it's structured differently. So yeah, for dflight Flutter, web's not supported, but there is a package that does support web, so you can use that one if you need it. Desktop requires building libraries. So as you saw before, I'm using Flutter Deck on my macOS. I had to build a library for that. It didn't work for me, and I found it somewhere on GitHub, so you can just download them as well. There is a very useful package, dflight Flutter Helper, which does some very nice things, but it's deprecated and actually doesn't work anymore. So it's very sad. They're talking about implementing it in dflight Flutter itself, but that's not done just yet. Loading the model, very easy. Just say interpreter from asset and then add your dflight file there. Not that difficult. Then pre-process the data. It is important. If you remember, we had our data set with values 25500. We then converted them to values between 0 and 1. You have to do it again here. If you don't do it here, yeah, it's going to give weird results. So it's not that hard to just divide by 255. I think we can all do that. And then we can put it into our model. And that's a bit weird because it's not something how we usually does things in Flutter. You're going to see we're first defining an output, which is a list, which has tensors in it, with a shape that is the same shape as our model. And it's a bit weird. And then we're going to interpreter run and give our input and our output. But then we get the output. Then if we use that output, it will have all the data that we want to see. So then the whole function looks like this. We're going to define our interpreter above somewhere. We're going to use our input divided by 255. Then we're going to use our define our output, run the model, and then we're going to use the result, for example here, to map the probabilities to labels. So that's this method right here. And for state management, I use setState. Some very important things here. Your models need to be lightweight. They are included in your eventual app. This model is very small because it's just an input and an output layer. As I mentioned before, models of 2 million parameters, not that difficult. It's going to be megabytes we're talking about. user privacy and on-device interference. So it's better to use the model on the device for privacy concerns. If you're talking about face recognition or detecting the face, if you're going to upload millions of faces, people are not going to like that. So putting it on the device is much better for privacy concerns, and it's also going to be real time. If we're going to do something to a face or something different that's not a concern privacy-wise, you can do batch inference, so upload multiple images and download them later on. You can do it on a server. Security, right now, if you're going to look at the demo, and we're going to do it later on, I just saved the TF-Lite file, I put it in the code, and I use that TF-Lite file. If your whole company is based on this one machine learning model, and you just shipped it with your app without encrypting it, people are going to decrypt your app bundle and just use your model. So yeah, use encryption if it's important. Then, very important, don't reinvent the wheel. There's so much machine learning already out there. You can just use existing stuff, only if you're doing something very custom. And the last one might be the biggest one. Don't use machine learning if you can just use a formula like we did here. This whole presentation could have been one slide. Instead of doing this all, just use this formula. No, that's important. Yeah, you don't need to use machine learning everywhere, and you have to be very vigilant that if someone says, we want to use AI, we want to use machine learning, that you first say, are you sure? I don't think that you should. So now we're going to see some more demos. If everything works as I would like. So we're going to show my screen. I hope. No. Could not find any device, of course. No. No. That's, yeah, this. And then have a little bit of patience. Yes. Yes, awesome. All right, so I'm first going to go and show you how the face detection is trained. So if we look at the file, it's IPYNDB. That's a Jupyter Notebook file. The cool thing is you can actually use this window here, the outline window. It has all your markdown stuff, and it automatically groups them based on the number you had. So first, install required libraries. We did that. The setup, easy. A bit harder to load the data set, but here we're just going to load images from a given folder. You'll see here that my data has images, has train and validation. And here you'll see a lot of images of people. This data set comes from Kaggle. I didn't took these pictures myself and definitely didn't label them. If you're downloading the GitHub, you won't see them there. You'll see a README file that says where I got them from. So then you'll have to download them yourself. Those are already split in a validation and a training data set, so we don't have to do it ourselves. We can just load them. Here you'll see my parameters, and here you'll see the learning rate decay, and then after how many epochs the learning rate should start to decay. Very fancy. You see the image size. It's a smaller image. It's just 96 by 96. The reason for this is how bigger the input, how bigger the model, how longer it will take to run the model. We want to do it live. We want to give the result immediately. We don't want to buffer every time it sees a face. So that's why I opted for a small image size, and then you'll see here it didn't work for 4 times, and then it finally worked just fine. So that's version 0.5. Over here you'll see how I parse the data set. If I open the data set, you'll see here it's going to be the same file name, but then a .txt file. And then this will be x minus y minus x max and y max. No, I'm wrong. X minus y minus width and height. Those are all already values between 0 and 1. So even for object detection, you also want to be the output values between 0 and 1. So then what does this mean? If you multiply this value with the width, that's where the bounding box starts. We do some maths, and then we sort it, and then we scramble it again. We validate that the data set is loaded correctly. So here you'll see the image being resized to 96. Not yet. You'll see the image loaded, and then the bounding box drawn on top of the image. Is this a person? Yes. All right, the data set's loaded. What you will notice is that there's only one person with a bounding box. That's because I decided to do it this way. It depends on how you want to structure your model. So this data set has a lot of multiple persons on one image. I tried with 3 people. The results weren't that great, and it's just for a talk, so I wasn't going to spend weeks on this. So I just say, okay, we're only going to take one person on the image, and for the labels, we're just going to take the biggest person there. Then we're going to create a model, and here you can see that I'm already cheating a little bit. I'm actually starting off with an existing model. Don't mind the terrain. I'm doing some mistakes here and there. This is a custom loss function. Why did I do a custom loss function? I wanted to know how much place there is different than the predicted one. This is not something I wrote. This is what ChatGPT told me I should do. Like I said, the difficult stuff, don't do it yourself. And then here you'll see how many parameters we have. So this has 2 dots, so 2,228,000 trainable parameters. So these are divided by 2, how many calculations that need to happen. So it's a lot. Then we can start predicting because we have a model and it will not be that good. So then we're going to train it to make it good. And here you can see, for example, the checkpoint saving. So it will save every time it has the best value loss. And it will do that after every epoch. And then we're also implementing early stopping, and that will just mean if we find a value that's not better that many times in a row, 5 times in a row, we're just going to stop the training. And this is pretty awesome because you then don't need to take epochs into account. So you can set it to a high value. For example, here it's 64. You can even set it to 1,000. It will stop when it's reached its best results in a while. So then we're training, and you'll see here some result after the 62 epochs. So we saved the whole 2 epochs by stopping early. And then we're going to check our validation over here, our loss. And then you'll see that the loss goes down and that the validation stays near the training loss. So this is a good graph. It would be better if it goes really down, but that's perfectly possible if we try and use a bigger model. But I didn't want to do that. And then these are some manual verifications. You'll see the first one is not that good, but that's why we take multiple. This one is good, this one is good, this one is kind of good. And here we can already see something we don't like. The data set contains more white people than non-white people, and so it might be a bit biased. So that's also something you'll encounter, models that are very biased. Which is not nice. But it does work eventually. So now I'm going to do the actual demo. And we're going to start off with a color recognizer. You've already seen this. It's just the same one, but here it's in a list. Then we're going to do face detection, and now you'll see here it's very fast, there it's a bit slower, but that's because I'm casting twice. But it's immediately. If I now go here and do this, you'll see it detects one person. That's what we want. And now we did all that to start doing fun things like putting on a hat. Awesome. This is why we need machine learning, so we can put on hats on people. Very nice. So then we can go even further. It crashes, don't worry about it. After you close it, it sometimes crashes. If we now see that this is a face, we can actually extract the bounding box. We can use that as an input for a new model, and then we can start to do really crazy stuff called segmentation. So I'm going to open segmentation here, and I've got two versions. I've got a smaller version because it was a bit too slow. But here you can really see the eye segmentation at work. So we have an input image, this one. We add a mask. That's the true value, and this is the predicted value. So this is actually what we're training on to detect eyes. Where are the eyes exactly? All the code is on GitHub. Go through it. It's a bit more extensive. Here you can see a completely custom model. It's a unit. So what it does is it takes your image, it makes it a bit smaller, it makes it a bit smaller, it makes it a bit smaller. Then it enlarges it, but then also uses data from that one, and it enlarges it, it uses it. Very difficult stuff. I don't understand it. ChatGPT does. Let it write it and just use it. And yeah, again, a loss function, sparse categorical, cross entropy, sure, why not? The good thing here is we can use accuracy as well as a metric. So this is the first prediction without training. You can see some very random values, but it does something. Then we train it, and then you'll see the training and validation loss and accuracy. And then you'll see here the validation and training accuracy starts at 1. So that means that 1 epoch was actually enough. It's not that difficult, apparently. And then you'll see some manual verification of a little baby here. But it detects the eyes almost immediately. The data set I use here, also available on Kaggle, uses input images from video. So that's why it's 5 times the same image. That's why it's important that we shuffle, so it doesn't learn the first face, then learns the second face. No, we want to learn all the faces. And then we can save it as TF-Lite, and then we can go really crazy, except for it's no longer connected. So if we go back, no, we can't go back the screen. Device found, yes, it's loading. All right, and now we can do the eye segmentation demo. You'll notice here that I just used 2 dots. Instead of coloring in the whole eye. We could color in the whole eye, but again, it was a little bit too much to do just for this demo. So I just used the center. If you're going to look at the code, it's also pretty extensive. And I'm going to go through the Python code just in a second. But here I have also included some more important data. You can see how long the image conversion takes, how long the image pre-processing takes, just the face detection, then cutting and processing the face, then the eye segmentation and the post-processing. And now, if we have 2 dots, can you guess what we're going to do? It's going to be awesome. We can add a sunglass. And then you can see, if we go side by side, it actually follows. And I can now switch the camera, so I don't need to run. But now I'm a bit too far, so my training set did not account for this. Now we're going to be really close. No, glasses don't work. model or frame. You'll see here it's a lot more complicated. So we're starting with the image as a camera image, then we convert it to something RGB that we can use. Then we're going to scale it and have the values between 0 and 1. Then we're going to make it a float 32 list, get an input tensor and put it in the right shape. These are some more complicated stuff, but in the end, running the model is again just one line. You just have to get it in the right format first. And if you have the output, you can easily do it times image face. Why there's a first bracket 0? Talking too long, the battery's running out? Yep. All right, apologies. The laptop battery is also running out, so we don't have that much time. It's because the model can run on multiple inputs as once, so that's why we do the 0 here. If you run on multiple, var 5, you'll obviously have to process each output. Here we're going to crop it then, given the face location. Then we're going to resize that copy. Then we're going to pre-process that resizing of the copy for the eye segmentation, put it in. Then we get the eye segmentation output, which will be a long list of values between 0 and 1 again for the whole image. So every pixel will have a value between 0 or 1. Is this an eye, yes or no? So then we have some code that we're going to find all of the eye segments, put them in lists, find eye regions. All very complicated stuff that I actually didn't need, but then I calculate the biggest regions, take the two biggest regions, calculate the center of it, and that's how I got those 2 points. All right, but in summary, those are just the 11, 12 steps you need to do to implement your own custom machine learning in your apps. I don't expect everyone to start working on it tomorrow, but all the code is on GitHub. Feel free to try it out. It's actually pretty awesome if you get something like this working. And yeah, you saw how fast it can be. It's always nice for a user to have some machine learning implemented. Just think about what you're going to implement before using machine learning, and if you need machine learning at all. Are there any questions? Thank you. Yes?
Is it only TensorFlow? Because currently in the AI environment, I think PyTorch is clearly the most used option out there. What is a general way to approach this? Do you convert your PyTorch models to TensorFlow then in Flutter, or can you, or are there libraries directly going from PyTorch to Flutter?
I've always used TensorFlow with Keras. Obviously, PyTorch or sklearn, or there are many different ways of doing this. I think a lot of them can be converted to TensorFlow, and once you have a TensorFlow, you can easily make a TF-Lite from it. I don't know which packages to use or anything. I have no experience with that myself. Yes? There.
So you talked about global and local minimum. How can you deal, is there some approach to when you reach a local minima to still get it out, success for the work?
Yeah, so if we're talking about local or global optima, local optima does not mean that it's going to be bad. It can still be near the global optima. So how do you deal with it? You just look at the output of your model and you see, is this good enough? If it's not good enough, then you're stuck somewhere that you don't want to be stuck in, and then you're going to play a little bit with your hyperparameters, or you're going to look at your input data. Do I have enough input data? Is it well balanced? Stuff like that is going to determine where you can change it. But how you approach something like this is you just first do every step, You go through it, you just do it, and then the output's not that great, and then you're going to optimize each step. You can spend months, years on just the first step, but yeah, you'll get stuck there then. Right? Yes?
Learning from the talk, I feel a lot of it is trial and error. Is that correct? Or are we missing a lot of guidance that you have that tells you should try this instead of that?
A good question. So the question is if this is a lot of trial and error, or if there is some knowledge that you're missing. I don't have a PhD. I don't have a master's degree. I learned this through trial and error. My experience is that that might be the best way. And from a developer background, I will say that this is the best way. I recently talked with people with PhDs about machine learning, and I explained them what I'm trying to do, and they said, no, impossible. That's not the developer mindset. We're always going to say, how hard can it be? And we're just going to dive right in. That's my approach to stuff like this. I did spend a few years failing a lot, but I was missing a starting point. I really had to start from nothing. Nowadays we do have ChatGPT, which we can rumble against, and it will give us ways of improving it. It's not always going to work, but eventually with common sense, with trying things, you'll know what works, what doesn't work. But there's not going to be a book that I know of that's just going to explain everything. You'll just have to figure it out. Yes?
Did you already apply it somewhere in practical cases for clients?
Yes and no. We're working on a project, and it's under NDA, so I can't say anything about it, but it's almost finished, so hopefully soon. Look at the socials from ICAPS for more news later on. Yeah. Any more questions? Yes?
Have you checked the Flutter implementation versus native Android stuff?
Currently, if you're talking about the TF Lite,
yeah, just TF Lite, just
yeah.
maybe native versus.
It's always using the native at the moment.
No, it's the same thing.
Yeah, okay. I have a crazy idea of using shaders for the complex stuff, but I have a little kid and no time, so for now it's not going to be Flutter. Okay, any more questions? All right, then that was my talk. You can see the packages I've used. You can download the presentation on GitHub. Find me on LinkedIn, but that's sabotaged. Find me, William Verhaeghe. And if you're interested, if I've inspired you, there are a lot of Coursera courses on machine learning. Look for Andrew NG. He worked at Stanford at the time. Those are really the best ones. They're free, they're open source. You'll get a certificate you can put on LinkedIn, as I did. If you're looking for data sets, use Kaggle, or try with YOLO. There's also some data sets you can use just to try things out. Yeah, forums, MOOCs, go YouTube, but most importantly, I use this ChatGPT. Let AI do the work, and you have the fun. Thank you.